And I kind of want you guys to start thinking about cybersecurity and OT a little differently. I want you to think more proactively. How oftentimes a lot of our cybersecurity programs are designed to be reactive. We wait till we're impacted. We wait till our production line's down. And part of what we're going to start talking about is using deception technology to get more proactive and protect your environments. And when I start thinking about security, I always want to use Dan Farmer's a very famous researcher, PhD, professor in cybersecurity, and I always think about security from this perspective. If it was all that mattered, we would never connect. We'd never even turn them on, right? If all we really cared about was protecting these devices. So when we start looking about security, we really want to think through what is it helping us enable? What is it helping us do that's expand on what we really want to be doing? Because we're not here to be security organizations. Our jobs are usually, to be manufacturers, to be water treatment, whatever it might be. But security is a byproduct of what we do. So when we focus on security, I want you to kind of think through, what am I helping enable, and am I thinking through the risks as I go to enable these different kind of digital transformation and modernization efforts? And one of the big things I always think about, we get asked a lot about is, are the threats real, right? What is actually hitting industrial environments? Because if you read the news, you'll see all types of articles on different hacks and different attacks. And it's important about a lot of those is a lot of those are kind of traditional IT enterprise side. But when you really look at the incidents and you drill down, you start to see there's a number of different incidents that have hit industrial environments, and specifically the three sectors that are probably the most hit, or not probably are the most hit according to ICS CERT, are energy, manufacturing, and then water. So those are the three most targeted ICS environments. And when we start asking, manufacturers, do they believe their infrastructure is vulnerable? Over half say they believe it is, and over right at 50% have been hit in the last 2 years. So when you start thinking about that, and you start thinking about the fact that we've got this huge acceleration uh, of vulnerabilities, and specifically just in last year, 70% of all the vulnerabilities were remotely exploitable. So that connectivity that's going along with all the other things that we're doing, kind of our transformation that we're going through, as we're adding that more connectivity, let's think about how we're going to protect our environments. So when we start looking at the traditional environment, so this is, for those who aren't familiar, this is kind of our mock-up of the Purdue model. And when you look at the Purdue model, it's designed to segment out the different processes within an industrial environment. So all the way down from the sensors in the process level, as you go to basic supervisor control, all the way up to the business network. When you start thinking about where security sits and how oftentimes we stop at that level 4, that's really where IT still plays. When we get to that DMZ and we start to get to level 3, this is where we start to see a lot less security. And when we do see security, a lot of times it's not security designed around an industrial mindset. So when we look at tools like what I'm going to talk about today with Deception Guard, is the idea behind creating a sandwich between that DMZ, that perimeter between you and other networks, creating a trusted kind of perimeter and hardening that environment, along with taking advantage of what the different techniques and tricks that the deception technology can provide. So what are the big issues we're trying to solve, right? Uh, the first, most organizations don't have a lot of resources dedicated to OT cybersecurity. A lot of times it's one or two people, and they wear multiple hats. They wear the infrastructure hat. They may wear the networking hat. They may also be a controls engineer. So security is really their only focus. So they've got very limited resources. And when we think about how we protect our environments, we're often very reactive. We wait till we're hit. We wait till production's down, and then we mad scramble to get everything remediated and back up and running. And then when we look at the tools we're using, a lot of times we're using, modified IT tools or enterprise tools that are designed to really focus on protecting Ethernet traffic and Ethernet networks. When we get down to our environments, we have Ethernet, but it's usually Modbus on top of it, or OPC UA, or one of 30 or 40 different industrial protocols. So understanding how an industrial environment is designed is important. And then when we think about it, we typically we focus on that perimeter, and making sure we have good controls on the perimeter is going to be important. And then last, just lack of network awareness and what's going on in our networks. A lot of times I talk to customers and the first thing I ask is, do you have an asset inventory? And it's usually some Excel sheet, and it's kind of been up to date, and kind of been worked on, but it's quickly, pretty identified as a definite gap in our knowledge of what's in our network, what's coming, what's transpiring across our barriers. So when we look at how do we solve that, right? So the thought process is we deploying deception guard, and the idea behind this is twofold. One is I'm deploying deception technology to divert threats away from my critical infrastructure. So I'm diverting them, deceiving them to come over into a sandbox or a deceptive network that is not really air quote fake devices. I don't really care what happens over there because I'm diverting them away. And because I'm sitting at that perimeter, I can actually enforce policy. I can guard against those threats. So that's really kind of where we got the name and where Deception Guard takes off from. So the idea behind I'm luring them away, and then I'm learning how they behave based on that sandbox. I can really identify a lot of valuable forensic information. So when we start thinking about it, how do we do this, right? So we sit by the firewall and we deploy a deception guard on each side of a perimeter firewall. And the idea behind it is we'll create this fake infrastructure of virtual devices. We call them Sirens. And the concept behind this is rather than having them impact my OT network and me reacting, I'm proactively luring them into my sandbox where I have more control over what they do. But on top of that, when someone enters in and they start trying to communicate with my systems, I can be alerted because there's no reason for communication to a bunch of fake devices. So I can alert against that. So I'm proactively preventing them from going over, but I'm also learning how they behave when they get into the sandbox. I can find out details like what port they came in on, what was their where they came from, what applications they were trying to reach, what assets they were trying to infect. So I can take a lot of this forensic knowledge and I can remediate it against my environment. And what I want you to think about is you're starting to turn these malicious actors into your pen testers. So they're going to identify what they're trying to do in your network. And because they're doing it on the fake network, you can really take that knowledge and get ahead of them on the actual network. So the idea behind this kind of deceiving and deception allows you to kind of get a higher value knowledge of how attackers behave in your network. So, what are the technical advantages of doing something like this? Well, the first thing is because we're a transparent bridge, there's a couple things we can get out of this. One, we can detect where they came from. So, if, for example, I start seeing a lot of traffic from a specific region, I can be alerted to that uptick in traffic. And because we track global networks like YouTube and Facebook and Google and all these massive, I think it's in the thousands of networks we track, I can also see if someone's trying to pull and extract data into one of the global networks, and I can prevent those global networks from communicating into my ICS. The simplest case of this is why would I want Facebook or LinkedIn social media into my ICS environment? I probably don't. So I can just proactively prevent that from that transaction from ever happening in my network. I can track the data flow, what were they trying to do. I can also control what they do in my network. So I don't have to just block them out. I can limit what they're allowed to communicate with. I can even go do what we call tar pitting and slow them down from network resources so I can limit their bandwidth. But then I can still use what they're doing to learn what's going on in my environment. And then lastly, because we sit on both sides of the firewall, and I think this is kind of something that's often lost when you look at like ransomware or IP theft or any data extraction, because we sit on both sides of the firewall, I can actually prevent that data from being pulled out of my network as well. So just like I can block it on the inside, on the outside coming in, I can block it on the inside going out. So that's a pretty valuable step when I'm thinking about that I can protect and I divert, but also if in case of an incident something happens, I can prevent that extraction, that valuable data extraction. I can kind of protect against that as well. So when we look at what do we really think that stands us out is one, we're vendor agnostic. We're going to work with what your infrastructure is. We're going to try to capture your traffic and rebuild your infrastructure. So when we build our sirens up, our fake devices, they're going to try to replicate the devices you have in your infrastructure. We can deploy passive or actively. So we can sit, we lose the ability to enforce policy, but I can be an alerting tool as well if I sit as a passive off a span port and just alert to people trying to communicate into my network. But really, the advantage is when you go active, I can actually put protections in place. And so it's designed to kind of protect both the perimeter from the business network to the process, but also I can protect the enterprise from the greater public internet as well. So if I want to kind of create multiple hardened perimeters, I can do that as well. And then kind of lastly, it's designed specifically around industrial environments. We're trying to replicate the way a PLC talks to an HMI, the way a device pulls out and does communications. We're trying to replicate that same so that when someone is on the outside doing their reconnaissance, we're identifying what they're trying to do, what they're trying to communicate with. If they're trying to look for a specific device, we're trying to replicate that same specific device. So, for example, if I take a PLC and it's an older version, and they're looking for that specific older version, we can alert to that because we're going to have that same older version encapsulated in our virtual environment. So we start thinking about that. The first thing we talk about doing is we build our sirens. These are fake assets. They do not exist in real life. But the idea behind it is we take the communications off your actual assets. We strip them down to just the base identifying information, and then we replicate that communication out. So, for example, if an HMI continually talks out to a PLC, we're going to replicate the back and forth communication between those devices. So we repeat that out. So it looks like not just a single device. So think the term honeypot, but multiple honeypots communicating. So they look less fake because there's actual communications on the network. And we're really trying to mimic the communication enough to get that and entice that reconnaissance scan. Because once again, these are fake systems, fake devices. So once someone starts reconnaissance scanning, starts trying to communicate with them, there's no reason. They do nothing. They're fake. I can then immediately be alerted someone's doing something in my network they're not supposed to be doing. So it really lets me highlight the value of diverting them away. But also at the end of the day, it lets me know I've got someone in my network and I'm proactively hunting them down. And we don't really limit the number of devices you can build up. So you can put up, 3 to 1 on what you actually have for assets. So you really go for that kind of needle in a haystack approach. Make it much more difficult to siphon through and find real assets because your fake devices are sitting out on the perimeter. They're much easier to get to, and there's so many more of them. So you can kind of use that strategic engineering of how you want people to behave in your network. And then at the end of the day, even to scanning tools, we really want to be able to pass as industrial devices. So if you look at CyberX or Tenable or Grass Marlin or any of the tools that are out there, we will look, our virtual network will look just like the PLCs you have in your actual network. In fact, in our lab, we have 2 or 3 different PLCs, but if you look at it from a scanning tool, it looks like we have 12 or 13 devices because of the way those scanning tools identify assets. So one of the big byproducts of this is the capability to create a fencing, either geo or GNL fencing. And the concept behind this is because I'm identifying where traffic is coming and going, what they're trying to communicate with, but also where they're coming from. If I see an uptick in traffic, so for example, all of a sudden I start seeing a high volume of North Korean traffic. I think that's a little odd. I should not get any of this traffic. I can immediately block all traffic coming from North Korea from touching my ICS network. So I've immediately shrunk my threat footprint down. And it could be any geolocation because it's going to identify all source and destination and even more granular in some cases of where that traffic is coming from. So you can be very, very specific on, I don't want to allow this traffic. I can even allow certain types of traffic. So I can say this port is open, or I only want to allow email traffic, or I only want to allow SNMTP traffic. I can decide what I want to allow. So I can, once again, shrink that threat footprint down. And because we're tracking global networks as well, I can do the same concept with these large scale global networks like Google or Yahoo or Facebook or LinkedIn or whatever. Like I said, it's close to 1,000 global networks we track. I can then parse those down as well. So I can, what I'm trying to do is shrink down the threats that I have to worry about and really harden my communication at my perimeter. So when you start thinking about this, the big value about this is that I'm shrinking. I'm not trying to solve all my threats, but I'm trying to shrink down the ones I have to worry about to a much smaller, more manageable volume. So if I start taking and eliminating everything else, it makes it much easier from a day-to-day operational standpoint. And then when we really want to look at this as such a new approach, because we're really combining both the ability to play offense and defense, right? And I use this in kind of 2 analogies. For a long time, we were describing this as kind of like a bear trap, right? Bear's in the woods. He sees this big juicy piece of bait, goes and grabs it. You spring the trap. And that's somewhat accurate. But I also want you to think about this a little bit like a crash test dummy. And the assumption is that someone's already in your environment. Crashes are going to happen. So why not do it on things that I don't have value in, I don't have big investment in, and then learning and remediating and improving my network behavior because of that. So if you think about the way a crash test dummy, the value of it is rather than risking human life, I can use a crash test dummy, perform crashes, take that data, and then improve the car safety. It's the same concept we're trying to do with deception technology. We're taking this fake environment, we're allowing it to be attacked. We're encouraging it to be attacked in some cases, but really at the end of the day, it's more the assumption that you're if you're exposed, you're diverting them away from the assets you've invested in, and then I'm going to learn about how they tried to get in my network, what they were trying to attack, what are the different things that could potentially impact my day-to-day operations. And since because they're doing it in that kind of sandbox, that learning, I can then remediate out and improve the security on my operational network. So when you look at the security philosophy, when we start approaching this, uh, I really want you to think about a couple things. Really, it's the standard paradigm of people, process, and technology. But you start off with the people, right? Are they following the best practices? Do they understand where the threats are coming from? The process, right? Do we have the right policies in place? Are we doing the right enforcement? Uh, I oftentimes talk about security versus practicality with our customers. I can be ultra secure and lock everything down, but it makes it very hard for me to do day to day. And then the inverse can be true. I can make it very easy and open and practical, but it's always getting attacked. So finding that core balance and using a tool like Deception Guard to find that balance is important. And then when you're looking at technology, make sure that you're investing in the right technology. Does it understand operational environments? Is it going to cover and protect the assets that I've invested in? Is it vendor agnostic? And have you evaluated what didn't work in the past to make sure that you can learn from those kind of mistakes? So, last little commercial for what GrayMatter does. I want to make sure you understand we partner with a bunch of really great companies. We do a lot of technology curation where we guide customers through helping them select the right tools, assessment work and risk assessments and vulnerability assessments, including compliance for things like AWIA. We're happy to do that kind of work and even do network design and policy creation.